turn this on. They show you the radius on all of these problems. You just got to think about how that impacts, what they're asking you to find here. They want to know what AB is, and they put A here and B here. So if you were to draw that straight line across, that's AB. Well, if you think about it, in each circle, they told you the radius of the circle, right? So on this first big circle, if the radius is 9 there, it might be better to look at your page because this is kind of sloppy, but it's the best I can do with the stylus. Each radius would be 9, so there would be 9, and there would be 9 more, correct? So that much of it is 18 on the first circle. And then on the second circle, they tell you the radius is 4. Well, here's a radius, so that's 4. Here's another radius. The diameter is 2 radii, right? So 4 and 4 would be 8. And then on the last one, your radius is 8, so here's 8. And here's 8 more. 8 and 8 is 16. And if you add them all together, you're going to get the distance, right? So let's see. 18 and 8 makes 26. And then you got 16 more, so that's going to be, you can use your calculator if you want to, 42, right? So 42, we'll put units here. Move on to number 7. Okay, number 7, if you notice, they have the center of the circle, P, and then they've got a point S out here, and they put a radius here. It's 8. And then they come here, and this is 15. Now, this paper did not clearly identify this, but you could kind of figure it out what's going on if you extend that line that has 15 labeled on it. It's a tangent, you're right. It looks more like a tangent on your paper. It's a tangent. So what do we know about, if I call that point, I'm going to call it R. If I call that point R, what do I know about PR and then this line that would go from S to R? What do I know about that angle created? It's a 90-degree angle. When you have a radius to a point of tangency on a circle, and then R is a point of tangency because it would just hit once and keep going, you get a right triangle. So how could I find this PS? Huh? Well, I don't know that it's a 30, 60, 90 because they didn't tell me any of the angles, so I can't really assume that. Well, think about the Pythagorean theorem. You got a right triangle and you know 2 sides of it, so we can find the third side that way. We're really not messing with angles here because they didn't tell us anything about the angles. We just know it's a right triangle.
So 8 squared plus 15 squared equals.
Right, Dakota. 8 squared.
TV isn't connected to this.
Let's list our special triangle. Since this was an 8, 15, 17, 3, 4, 5.
6, 8, 15.
Let's see. We had, 5, 8, oh my goodness, my brain is not working today, 25 and 64. Oh, no, that's not it. 5, 12, 13, duh. 5, 12, 13, 8, 15, 17, and then there's another one that's 7, 24, 25. I would write those at the top of the paper if you don't know them already, just because I suspect that they're going to get used a lot in here. So you got a circle and you got a point out here, and they don't really draw the point, so you kind of have to think a little bit. If you extended this is going to be a tangent line. It's really going to hit only one point on the circle, even though my fat marker now makes it look like it's hitting a whole section. Here's what we know. From a point outside the circle, if I draw from that point the tangent line to each side of the circle, then these segments are equal, okay? So if I want to solve number 5, they tell me this side is 3x plus 4, and this side is 40. So if they're equal, aren't we just going to set them equal to each other and solve for x? Because that's what they want to know, is what's x here. So anytime you see 2 tangents drawn from a point to the circle, you notice there's 2 possible tangents, and so they drew them both in. They're going to be equal, and that's what you're going to use on this problem, and problem number 2, and problem number 3, and I guess that's it on this page. But if I set these equal to each other and solve for x, we get, subtracting 4 from each side, we get 3x is what, 36? And now if I divide by 3 on each side. X is going to be what? 36 divided by 3 is 12. Okay, so here I suspect we're going to have to draw some lines in. So one of the things I'm going to do is I'm going to come in here and put the center of the circle. I think it's telling me, let's see, I'm drawing a radius here. I think it's telling me that from here to here is 3, and like from here to here is 4. And then x, if x is the whole thing, okay, I wish I had not drawn that. That would also be, I don't know, let's skip this one. There's something here I'm not thinking of. And I don't think, yeah, put skip on 6. I'll think about it and get back with you guys on it. I just don't want to waste too much time here because I'm not sure what they're labeling.
Does 8 use the Pythagorean theorem?
Yeah.
Yes.
Okay.
And that hypotenuse there on 8, what would it be, the whole hypotenuse?
15.
Yeah, you'd have to add them together. They're telling you the radius is 9, okay?
What I thought.
Okay.
Oh, crap, I just got that. I should have done
All right, let's move to 12. Trying to think. Isn't AB a tangent line to that small circle, right? So if I draw in a radius from the center to that, I know now that I've got a right angles there, right, correct? There's right angles, so I'm going to have a right triangle. Now what, so the red line is the small circle, radius is 5. Okay, now I'm going to draw on a different color. I'm going to draw the large circle radius, and look where I'm going to put it. I'm going to put it right there. So the radius, large radius is 13. So didn't I just create a right triangle with that? Because I know that tangent line is perpendicular there. This could be another good SAT problem. If I separate this out, I know that this red piece was 5, the green piece was 13, so I'm missing the side here that comes from the red dot out to B, and they want me to find AB. Let me call that M there, okay? I'm going to call that M. What now, Charlotte?
5, 12, 13.
Well, it is, and then I'm going to have to do something to it, right? Isn't this a 5, 12, 13, just like Charlotte said? Okay, so you could do the Pythagorean theorem, but see how much nicer that is. It's just to look at it and go, ooh, it's 12. So let's fill it in. It's 12. But AB, isn't that double that length? So it's 24. Like I said, 24 would be the answer there. So you've got to, you create these right triangles is what you're looking to do a lot of times in these. Be a good one to go over just to make sure y'all got what you were supposed to get out of this circle stuff, the central angles and all that. So if you look at this circle, you got P, A, C, and then B, and then D. Oh, great, that was just a wonderful looking circle. But let me, huh?
Do you have to do part of the whole for this one?
Well, probably not. Just hang on a second. Let me change this down to something a little bit. All right, so here's the thing. They want to know, or let's just do one at a time that they ask. ACB would be ACB. Now, here's the deal. This is 42 degrees. This is 130 over here. You might want to look at your paper because I drew a really bad circle here. If we want ACB, let me turn it on. ACB, I'll trace it in green, would be this. Now, here's the problem I see. They're not giving us a radius, so they're wanting us to tell it in degrees. How are we going to figure out? We got to know something else here. We got to find a way to figure it out. Which one can you find? And you can't tell it from the circle I drew, right?
The diameter cuts it in half.
That's right. So this piece here, you can't tell it on my circle, but if you look on your paper at number 12, isn't that going to be 180 minus 130, which would give you 50? We had to know that to answer these questions because we got to know, do you remember that whatever the central angle is of an arc, whatever the measure of the central angle is, that's the arc measure in degrees. So if I want ACB, I still need to go figure out this big piece up here at the top So now I can say, well, I've got all the other three pieces. What's a whole circle? 360. So let's subtract 360. We knew these two added up to 180. So that leaves us with 180 if I subtract this one and this one. And then subtract 42 more.
138.
Yep, 138 is this top part here. So now I got to see what the angle measures are for this ACB that I just am drawing in orange here. If I add up those central angles, that's 138 and 42. Why isn't it writing? Here we go. 138 and 42. 180, okay. So that gives me 180. I probably could have told that if I had drawn it decently enough, right? That's why I was saying, look at your paper. It just didn't come out right. I was adding and then I was kind of trying to get it to write. It just did not. I just had trouble writing on the iPad and getting it to look right. So that one's 180. What would BC be? 42, because that's the measure of its central angle. Good. What would ADC be?
Couldn't you just do 180 or?
You know this big arc is 138, so could you?
130 plus 42 is 180, so then you could do 360 minus 180.
Well, if you look, it's if you want, let me draw it in a color so we can see. They're just asking us for ADC. Isn't that the whole thing except for this arc? Right? If I took this out, it would be the whole thing, right? So 360 minus that big arc 138, which would be oh my gosh, I can't subtract in here. 222, is that what y'all are getting? Let me use my calculator because my brain is apparently not deciding it does not want to cooperate today. It is 222, it just didn't sound right. Okay, so ADC would be 222. It would be the whole thing minus just that blue part that I colored in. So that would end up being 222 degrees. And so what would DB be? What's its central angle? 50, right? Yep, thank you.
So wait,
What now? What were you asking, Misha?
wait,